Welcome to Wizznotes.com Mathematics Video Tutorials.
Question 10b. It says a boat left a point P and traveled 65 kilometers on a bearing of 325 degrees to a point R. Another boat left the same point P and traveled 90 kilometers on a bearing of 0.75 degrees to a point S. Draw a fully labeled diagram to represent all information presented, and we have to show the north direction. Part 2, we have to calculate the distance RS in kilometers, and then we have to determine the bearing of S from R. So based on the information given, what we must recognize is that in the journey from P to R, P is the from position, and we always measure our bearings at the from position. Now remember, bearings is our clockwise angle from the north direction to the direction between the 2 points, and the bearing must be measured at the from position. So for this part of the journey from P to R, P is the from position. Alright, so we're gonna first bring in our frame for our sketch. Alright, so we're gonna be doing our sketch in that frame, and our first point of interest is our P. So let's go ahead and bring in our P, and P is our from position. Right, so put in a point P as our from position. Now we must put our north line at P, because the bearings will be measured clockwise from the north line. So that's our north line at P. Now the bearing of R from P is 325 degrees. So it's clockwise from the north line, 325 degrees. So there is our clockwise angle. See, start clockwise from the north line, clockwise direction, 325 degrees. Alright, so then we can put in the line which represents the line from P to R, such that it is 325 degrees, and that's a line. Now the distance is 65 kilometers, and in your exam you would typically just draw a line that is 6.5 centimeters, so that your diagram is somewhat to scale, so you get a somewhat of a true representation of the real situation. So at the end of that line, what we're going to do is put in a point R. Alright, so there is our point R, and that's the first part of the first boat. Alright, now the second boat, another boat left P, so P is the from position now for the second boat, and traveled 90 kilometers on a bearing of 0.75 degrees. So again, we need to put in our 0.75 degrees from the north line at P, and the angle must be clockwise, so we can go ahead and put that in. So there is our 75 degrees clockwise from the north line, and then we can go ahead now and put in the line from P that will take us now to point S. So that's it. So this line is 90 kilometers. That's the distance from P to S, 90 kilometers on a bearing of 0.75 degrees. So clockwise from the north line at P to the line joining P to S, which is this line here, the angle is 75 degrees. 0.75, we have just left off the 0, but the angle is 75 degrees. Alright, so we can now put in the point S. Alright, so S is going to be at the end of this point, and again, to make it somewhat to scale, this line we would draw a 9 centimeters line, such that the distances are somewhat relative to each other, and it is somewhat to a scale. Alright, now what we can also do now is just show the line that represents the distance between R and S. Alright, so that is that line, and we have therefore completed our triangle of interest. Now that would be the diagram representing the information. You must show the north line, that's our north direction. We must show the bearing angles, This would be the 325 degrees bearings from P. This would be the 75 degrees bearing from P to S. This is a 90 kilometer, the distance of S from P. This is the 65 kilometer, the distance of R from S. And there is our north direction. N is representing our north direction. Or you could actually write out the word north here. Alright, but N is usually accepted as representing north when we are doing bearings questions. Alright, now the second part of the question is that you have to calculate the distance RS. That is this distance RS. Alright, now in order for us to calculate the distance RS, what we find is that we are going to need angles inside the triangle to calculate the distance RS. So far we have this angle as 75 degrees and this angle as 325 degrees. So far we have no angle. We don't know the angle between these two sides. We don't know the angle between these two sides, and we don't know the angle between these two sides, but we can deduce those angles, because if we look at the 325 degrees, to complete the circle we need 35 more degrees, because total angles in a circle is 360 degrees. So this angle here between our north line and this line PR, this angle here, can be calculated by subtracting 325 from 360 degrees, and that angle would be 35 degrees. So we can actually go ahead and put that angle in. Alright, so that angle would be 35 degrees, and based on that now we know this total angle inside the triangle here is 35 plus 75 degrees. That will be the angle inside here. Now we are asked to calculate the distance RS in this triangle. Now this is not a right angle triangle. PRS is not a right angle triangle, so we therefore cannot use Pythagoras' theorem, and we also cannot use the trig ratio for sine, the trig ratio for cosine, or the trig ratio for tangent. Right? When the triangle is not a right angle triangle, we have to look to use the sine rule or the cosine rule. Right? Now we typically use the sine rule when we have a known angle, as we have here, because this would be a known angle, and a known opposite side, but we don't know this opposite side. Right? So therefore we cannot use the sine rule. But however, we can use a cosine rule, because we typically use a cosine rule when we have two sides, two known sides, and a known angle between the two sides. So this triangle now is a typical case for the use of the cosine rule. Alright, so to calculate the distance RS, what we're gonna have to do is use the cosine rule in this triangle. Alright, so the sketch would basically be our first answer, and then we're gonna look now at applying the cosine rule in the triangle. Alright, so we say using the cosine rule in triangle PRS gives, and the cosine rule would be, and we put it in and then explain what is happening. The cosine rule is that the side opposite the angle squared, RS squared, is equal to this side squared, 65 squared, plus that side squared, minus 2 times this side times that side, multiplied by the cosine of the angle between the two sides, which is 35 plus 75. Alright, 75 plus 35. So that is the cosine rule. This side squared is equal to this side squared plus that side squared minus 2 times this side times that side, multiplied by the cosine between the two sides, two known sides. Hence that is our cosine rule. And when we have worked these figures out, we are going to get that RS is therefore going to be equal to the square root of this, because if RS squared is this, then RS is going to be equal to the square root of whatever that figure is. So we can put that in, that RS is now equal to the square root of whatever this figure works out to be. So this part works out to be that minus this works out to be 17,700, and this now is the cos of 110 degrees. So we plug all of this in our calculator correctly, and we end up with what the distance of RS is right here. Okay, so far so good, and the distance of RS is in kilometers. So now that we have worked out the distance of RS, we can go ahead and put it on the diagram, right? And we normally put the equal sign in front when we calculate a value, and we put it on the diagram. We put the equal sign to indicate that we actually did calculate this side. These were actually given in the question, right? But this was calculated, hence we put the equal sign in front. Alright, so that's the answer for the second part. Now we have to determine the bearing of S from R. R is a from position, so we need the bearing of this point from this point. So R is a from position. So our first order of business is to put in our north line at the from position. So let's go ahead and put that. That's our north line at the from position. Alright, and if you notice, we drew the north line all the way through the point, and the reason for doing that is that we might need angles, these angles here, and the bearing of R of S from R is actually a clockwise angle from the north line to the line that takes you from R to S. So it's this angle here clockwise. So let's put on that angle. Alright, so on the diagram, that angle is going to be that one, which is, we're going to call it theta. Alright, we're going to call the angle theta. Alright, now in order to calculate theta, what we are going to have to do, we're going to have to come inside the triangle and calculate this angle inside here, and we also need to know this angle. Then we apply the theory of total angles on a straight line. But if we look here, there's a parallel line. This north line is parallel to this one, right? So basically I have a Z angle. There is our Z. There is our Z. Remember now, Z angles are equal. So what it means is that this angle here is equal to this angle here, which is 35 degrees. So we can go ahead and put that angle in. More angles we have in the information, the better we are able to work out our solution. So you see, if we can calculate the angle inside here, then we can use the theory of the total angles on a straight line, which is 180 degrees, and hence we can calculate theta. Alright, so let's put that angle inside the triangle here, and let's call that angle alpha. Alright, so let's put in our statements now. First, we're going to say that in the diagram as it is now, in the diagram, the bearing of S from R is theta. But based on that information that we have, right, theta is going to be equal to 180 degrees minus 35 minus alpha, because total angle on a straight line is 180 degrees, and therefore theta is equal to 180 degrees minus 35 minus alpha. There's another theory that we could have used, and that is the internal angle between parallel lines. That's here. The sum of the internal angle between parallel lines is 180 degrees. So what we're saying is this theta plus alpha plus 35 degrees is 180 degrees. So that will give us the same expression, right? This angle theta plus alpha plus 35 degrees would total 180 degrees, because with total interior angles between parallel lines. So this will be one and this will be one. The angles between the internal angle between parallel lines are supplementary. They add up to 180 degrees. So that's another theory we could use to derive our answer. But in any case, we need to find the angle. We need to find the angle alpha inside the triangle. So we're going to go inside the triangle and find angle alpha. Now that we know this angle and we have a known opposite side, we have a known angle here 110 degrees and a known opposite side, we can use a sine rule, because that is when you typically use a sine rule, when you have a known angle and a known opposite side. Alright, so we are saying that we need to find alpha, right? We need to find alpha, and we're going to be using the sine rule in the triangle. And since we want to find alpha, we use the sine rule ratio where the sine is on the numerator, right? Sine is on the numerator. So what we are saying is that sine of this angle divided by the opposite angle, opposite side, sine of this angle, which is sine alpha, divided by the opposite side, which is 90, is equal to the sine of this angle, which is 35 plus 75, divided by the opposite side, which is 127.8 kilometers. And that's the use of our sine rule. Remember the sine rule, you can use the sine of angle over opposite side equals sine of angle over opposite side, or you can use side over sine of opposite angle equals side over sine of opposite angle. But since we want to find alpha, we start with sine of angle over opposite side, and this will reduce to, if we transpose, right, if we transpose, we multiply the 90 across to get this. So we're gonna end up with sine of 110 degrees over 127 multiplied by 90. We multiply both sides by 90 to get rid of this 90, and then sine alpha is going to be equal to this, and therefore alpha equals the sine to the minus 1, the inverse sine of this angle, and it works out to 41 degrees. So since alpha is 41.4 degrees, pardon me, 41.4 degrees, so since alpha is 41.4 degrees, then what it means is that theta is 180 degrees minus 35 degrees minus the 41.1 degrees that alpha worked out to be, and our result is 103.6 degrees. And we already stated that the bearing of S from R is theta. So once we put theta equals this, it means that we are saying that the bearing of S from R is 103.6 degrees. All we need now is to put in our degrees. Right, 106.3 degrees, and that's our answer. Okay, thanks for watching this solution on Wizznotes.com. Hope you learned a lot, and you can visit us again at Wizznotes.com for more solutions in mathematics. Okay, bye.